Hello and welcome to Unit 2, Lesson 8. This lesson is on free fall. And you've all probably experienced free fall if you've ever fallen off something and hit the ground, or if you've ever thrown something up in the air and caught it. You've had some real-life experience with free fall. So let's get started with a definition. First of all, what do we mean by free fall? Free fall is basically talking about an object that is in motion and subject only to the force of gravity. That's what we mean by being in free fall. The only force acting on you is gravity. So there's no significant air resistance. There's no engine or thrust force acting on you. There's just you falling through the force of gravity. We call that free fall. So gravity is what is causing this motion, and it's basically a force that causes a constant acceleration of objects on Earth. And when you're near the surface of the Earth, we use an acceleration of 9.80 meters per second squared. That has been measured and proven experimentally to be the actual acceleration of objects when they're close to the Earth. And we use this little letter g, a small g, to stand for the acceleration of gravity. So whenever you see a small g in a formula from now on, you should think that's the acceleration of gravity. And for Earth, that number is 9.80 meters per second squared. We're going to be using that in some problems later on, so keep that in mind. Now, we have some formulas for free fall, and they are the same formulas we've already worked with before. They're basically the constant acceleration formulas. So really, this is just another constant acceleration problem, but it's a special type of constant acceleration, which is a constant acceleration of negative g, or negative 9.80 meters per second squared. So these are your formulas for x, velocity. X is your displacement, v is your velocity, and of course this is the velocity squared formula we used before, which is useful when you don't know time. Okay, so to find how far you fall in x is your initial velocity times time minus 1/2 the acceleration of gravity, which is 9.8 for Earth, times the time squared, or how far or how long you've been falling for, squared. Your velocity is found by taking your initial velocity and subtracting your gravitational acceleration, 9.8 times t, or time in seconds. This will tell you how much you've changed your velocity right here, that's term, negative g times t. And then finally, if you don't know the time you were in the air for, you can find the velocity by using the velocity squared is the initial velocity squared minus 2g times your displacement, or how far you've changed your position while you're falling. So if you know how far the object's fallen, you can also find the velocity using this formula here. This is also a good way to find the distance traveled if you know the two velocities as well, and we've done that before. So let's look at an example of free fall and a non-example of free fall. First of all, let's look at an example of something that is experiencing free fall.
4, 3, 2, 1. Oh goodness.
As you can see, that pumpkin experienced free fall as it was dropped from a window. There is really no significant force except gravity acting on the pumpkin, and that pumpkin accelerated downward at 9.8 meters per second until it hit the patio and split open. That is a good example of free fall. Now, let's go ahead and look at a non-example of free fall. And let's watch the video and we'll see something that is not a free fall. This guy is getting out of his apartment by going to the balcony, and he's going to use, conveniently, a tree located next to his apartment to get to the ground. Now, think about that. Is that free fall? The answer, of course, is no. That's not free fall, because this person is using the tree as a elevator. So he is using the force of the tree to slow him down. So he's not accelerating at 9.8 meters per second squared. So that is not free fall. So let's do some example problems now. These are in your notes. The first example problem says a ball is dropped from a window. How fast is it going after 1 second and after 2 seconds? So we're going to draw a coordinate system, and the ball will be dropped from a position of 0, and we're showing the coordinate system, the direction of motion will be downward. So this ball will accelerate downward, and it's a constant acceleration. We'll call it negative g, or negative 9.8 meters per second squared for the acceleration. We want to figure out the velocity of this ball at 1 second and 2 seconds. So we know that the initial position, or x0, is 0 meters. We know that it's starting with a velocity of 0 meters per second, and we know that because the word drop there. If it's dropped, it means it has no velocity at the beginning. So v0 equals 0. V final, we don't know what that is, so we want to find V final. We're going to put a question mark there. We know the acceleration is negative 9.8 meters per second squared because it's a free fall problem. We recognize that. And we know that we want to find the velocity at 1 second and 2 seconds. So we're going to do basically two parts of this problem. The first part, we'll look at the velocity after 1 second, and then we'll look at the velocity after 2 seconds. So we're trying to find velocity. If you look at the formulas I just gave you for free fall, the formula for velocity is V final equals V0 minus G times T, or the initial velocity minus acceleration times time. Plug in 0 for the initial velocity. We plug in 9.8. Wherever you see G, you just put in 9.8 meters per second squared as the acceleration of gravity. And T is 1 second. We want to figure out how fast it's going after 1 second. So my final velocity after 1 second, and I'll put a 1 there in parentheses so notice 1 second is the velocity we're looking at here. It comes out to be negative 9.8 meters per second. So that is our first part of the problem. We now figured out that after 1 second, this ball has a velocity of 9.8 meters per second downward, or negative 9.8 meters per second. What about after 2 seconds? Well, we're going to use the same formula. The final velocity is the initial velocity minus acceleration times time. And we're going to plug in the same numbers, except instead of 1 second, now we're going to look at 2 seconds. So the initial velocity is 0 meters per second minus acceleration 9.80 meters per second squared times 2.0 seconds. And we put that in the calculator, and it comes up to a number of, I believe it's negative 19.6 meters per second. So after 2 seconds, we now have a velocity of negative 19.6 meters per second. So you notice that every second, this ball is falling faster towards the Earth. It's increasing its speed by 9.8 meters per second every second. So now after 2 seconds, my velocity is negative 19.6. Let's do another example. Let's look at one more example problem. And you remember we talked about the Red Bull Stratus project, and Felix Baumgartner jumped out of the space capsule. Here we have him dropping out of the space capsule. We want to know how far has he fallen in 12.5 seconds if we assume no air resistance, which out in space, that's a pretty good assumption. So again, we're going to draw the coordinate system here, showing him starting from a 0 position at the space capsule, and he's going to be falling downward towards the Earth with an acceleration of negative g, or 9.80 meters per second. Now, just to let you know that at that height above the ground, it would probably be a little less than 9.80, maybe 9.7, but we'll just use 9.80 for now, because that's the acceleration we use close to the Earth. We're going to say we're trying to find how far he falls, which is xf. We know his starting position x0 is 0 meters. His starting velocity, 0 meters per second, because it says he just drops out of the capsule, so he's not really having any initial velocity. And he's going to fall for 12.5 seconds, so that is my t, or time. So what I'm trying to find is the final position x, and if you look at your formulas for free fall that I just showed you, to find the final position, it's going to be the starting position x0 plus initial velocity times time, v0 times t, minus 1/2 acceleration times time squared, or gt squared. Again, g is the acceleration because we're in a free fall problem. So since x0 and v0 are both 0, I'm going to cross those two terms out. They both go away because they're both 0. And it simplifies my formula to just be negative 1/2 times g times time squared. Now I can go ahead and plug in my numbers. G is 9.80 because we're close to the Earth. 9.80 meters per second squared times a time squared of 12.5 seconds. We need to square that number. Don't forget to square the time. And you put in the calculator, negative 0.5 times 9.8 times 12.5 squared. And I get a final answer on my calculator of, let's see here, comes out to be about negative 765.625. That's what the calculator gives you. And of course my units are meters. The distance he falls in meters. So I need to figure out how many sig figs. Well, since my time is given as 12.5 and that's 3 sig figs, I need to round this answer at the third significant digit, which is the 5 here. So I'm going to round this up to negative 766 meters. My final answer is he falls about negative 766 meters in those 12.5 seconds.